Hello everybody. In this lesson we will study about Pythagoras theorem. What is Pythagoras theorem? What is the converse of Pythagoras theorem? And how we can use the Pythagoras theorem to solve problems of triangles. So welcome to the lesson. Before we get to understanding Pythagoras theorem, let us first understand another concept. Let us consider the triangle ABC, right angled at B. That means angle B is 90 degrees. And let us draw BD, a perpendicular line to the hypotenuse AC. So let's get to this information. So AB is a triangle, angle B is 90 degrees, and we have drawn BD perpendicular to the hypotenuse AC. So it is dividing the triangle into two triangles over here. Now in triangle ADB and ABC, what do you observe? ADB, this triangle, and the whole triangle ABC. Can I say angle A is equal to angle A? Why? Because angle A is common to both the triangles ABD as well as ABC. And can I say angle ADB is equal to angle ABC? Angle ADB, this angle, how much is that? 90, is equal to ABC. How much is angle B? Right angled at B. So angle B is also 90. So ADB is equal to ABC. So two angles of a triangle are equal to two angles of the other triangle. So can we say that triangle ADB is similar to triangle ABC? How? According to angle criterion. Let us label that as equation 1. Now let's consider triangle ADB and triangle ABC. So if we consider triangle ADB, similarly what will you have? You will have BDC similar to ABC. Let's label that as angle 2. So angle ADB is similar to ABC and angle BDC is similar to ABC. So can we say that ADB is similar to BDC? So if triangle ADB is similar to ABC and triangle BDC is similar to ABC, then triangle ADB is similar to BDC. So we can come up with a theorem over here. And that is, if a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. So if we draw a perpendicular line from the 90-degree angle of a right angle triangle to the hypotenuse, then each triangle will be similar to each other and they will be similar to the whole triangle ABC. So this is a theorem that we can use to prove Pythagoras theorem. Let us see how we go about proving Pythagoras theorem. So what is Pythagoras theorem? In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Suppose if we have a right angle triangle, right angled at B, angle B is 90 degrees. Then AC is the hypotenuse. So the Pythagoras theorem states that AC squared is equal to AB squared plus BC squared. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Can we prove this? Of course we can. So let's go ahead. So we are given a right triangle ABC, right angled at B. So angle B is 90 degrees. And we draw BD perpendicular to AC. So BD is drawn perpendicular to AC. Then in triangle ADB and triangle ABC, what can we say about these two triangles? This triangle and the big triangle ABC. Can we say that they are similar triangles? Because we learnt it just few moments ago. So triangle ADB is similar to triangle ABC. How? According to theorem 6.7. So if the two triangles are similar, then the ratio of their corresponding sides will be in proportion. So can I say AD over AB is equal to AB over AC? AD over AB is equal to AB over AC, the proportionality, because sides are proportional. Now if we cross multiply, AD times AC equal to AB times AB. If we cross multiply, we get AD times AC is equal to AB squared. Let's label this as equation 1. Similarly, if we consider triangle BDC and triangle ABC, we learnt that triangle BDC will also be similar to ABC according to the previous theorem. So triangle BDC is similar to triangle ABC. So if they are similar, then the ratio of the corresponding sides will also be similar. So CD over BC will be equal to BC over AC. Proportional sides will be similar. Corresponding sides will be proportional. So if we cross multiply, then CD times AC equal to BC times BC. So that's going to give us CD times AC is equal to BC squared. Let's label this as equation 2. Pretty simple so far. So what's our equation 1? Remember that? AD times AC is equal to AB squared. This is our equation 1 and this is our equation 2. Now, can we add them both? If we add them both, AD times AC plus CD times AC will be equal to AB squared plus BC squared. So we can add 1 and 2 and we get AD times AC plus CD times AC is equal to AB squared plus BC squared. Is AC common in both? So can I remove AC as a common factor? So what do I get? I get AC is equal AC times AD plus CD. Removing AC as the common factor, we get AB squared plus BD squared. But what is AD plus CD? It is nothing but AC. So AD plus CD is nothing but AC. So this will become AC times AC equal to AB squared plus BC squared, which is nothing but AC squared equal to AB squared plus BC squared. And the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the two sides, and thus we have proved the Pythagoras theorem. So this is the Pythagoras theorem, AC squared equal to AB squared plus BC squared. Now what is the converse of the Pythagoras theorem? The converse is, in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. What does it mean? Suppose if you have a triangle, and if in the triangle AC squared is equal to AB squared plus BC squared, then angle B is 90 degrees. So that is the converse of the Pythagoras theorem. Let's try this problem, which is actually the converse of the Pythagoras theorem. Sides of a triangle are given below. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. The sides given are 7 centimeter, 24 centimeter and 25 centimeters. We know that the converse of the Pythagoras theorem, AC squared is equal to AB squared plus BC squared. So if that is equal, then it is a right angle triangle. And we also know that the longest side of a right angle triangle is the hypotenuse. So let us try to figure out whether the Pythagoras theorem holds good or not. So how do we go about? We must first check whether 25 squared is this equal to 7 squared plus 24 squared. Let's check. We don't know whether they are equal or not. How much is 25 squared? It's 625. Okay. How much is 7 squared? 49. And how much is 24 squared? 576. Add them both. 625, 625. So they are equal. So we say that it is a right angle triangle. So it is a right angled triangle. And what is the length of the hypotenuse? It is 25 centimeters. So that is how you show whether the three sides of the triangle form a right angle triangle or not. Let's try this. The three sides of the triangle are 3 centimeters, 8 centimeters and 6 centimeters. Do they form the sides of a right angle triangle? So let's test the Pythagoras theorem again. Let us see whether 8 squared is this going to be equal to 3 squared plus 6 squared. Let's check. 8 squared is how much? 64. Okay. 3 squared is 9 and 6 squared is 36. And 64 is not equal to 45. So they do not form the sides of a right angle triangle. So get that idea now how you do this? Great going. Let's move forward and take up some more problems. Let's try this. In the triangle, angle ACB is 90 degrees. ACB. So that means angle C, complete angle C is 90 degrees. And CD is perpendicular to AB. Prove that BC squared over AC squared is equal to BD over AD. So we know that if this line is perpendicular and if this is 90 degrees, then this triangle is similar to this triangle and each triangle is similar to ABC. We know that from the theorem 6.7. So triangle ACB is similar to triangle ABC. We know that. So the corresponding sides will be in proportion. So AC over AB will be equal to AD over AC. So cross multiply. So we get AC squared equal to AB times AD. Let's label that as equation 1. Similarly, if we take triangle BCD and triangle BAC, they too will be similar. So triangle BCD will be similar to triangle BAC and the ratio of the corresponding sides will be same. So BC over BA will be equal to BD over BC. So cross multiply, so we get BC squared equal to BA times BD, and let's label that as equation 2. So from 1 and 2, this is equation 1 and this is equation 2. So BC squared over AC squared, because the question says prove that BC squared over AC squared. So what do we get? We get BC squared over AC squared equal to BA times BD over AB times AD. And BD and AD, BA and AB, they are the same thing. BA, AB, it's the same thing, same length. So that is nothing but it's going to be equal to BD over AD, hence proved. Let's try this. A ladder is placed against a wall such that its foot is at a distance of 2.5 meter from the wall and its top reaches a window 6 meter above the ground. Find the length of the ladder. So let's CA be the wall, which is 6 meter tall, and let the foot of the ladder be away from the wall, and that is 2.5 meter. We need to find the length of the ladder. That means we need to find AB and let that length be x. So let's try to work out the problem. So this is a Pythagoras theorem. Why? Because angle C is 90 degrees. So this is a right angle triangle. So we can apply the Pythagoras theorem. What is the hypotenuse over here? It's x. So according to the Pythagoras theorem, x squared is equal to 6 squared plus 2.5 squared, and x squared is equal to 36 plus 2.5 squared, which is 6.25. Add the two and you get x squared is equal to 42.25. Take the square roots on both sides in order to get x. So square root and square cancels. So x is going to be equal to 6.5 meters. So the length of the ladder is 6.5 meters. That is how you apply Pythagoras theorem to application problems. Let's try this. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. Once again, 8 meters is the height of the window from the ground. 10 meter is the length of the ladder. We need to find the base of the ladder from the wall. And we know that this angle is 90 degrees. So it's a right angle triangle. We can apply the Pythagoras theorem. So according to the Pythagoras theorem, 10 squared is equal to x squared plus 8 squared. So 10 squared minus 8 squared is going to be equal to x squared. 10 squared is 100 minus 8 squared 64 equal to x squared. So 36 equal to x squared. Take square roots and x is going to be equal to 6 meters. So the base of the ladder from the wall is 6 meters away. Let's try this. An aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. So we will take the aeroplane flying from O to A northwards at 1000 kilometers per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 kilometers per hour. How far apart will be the two planes after 1.5 hours? So we need to figure out what is the distance between AB. So now let's look at first how to find out the distance OA and how to find out the distance OB. We know that the plane A has traveled 1000 kilometers at the speed of 1000 kilometers per hour, and it has traveled for 1.5 hours. So how will you calculate the distance? It's nothing but speed times time. So we can easily find OA to be, OA is going to be the speed, which is 1000, times time for 1.5 hours. 1.5 is nothing but 3/2, and that is going to be 1500 kilometers. So 1500 kilometers. So that is the distance. OA is 1500. Similarly, we can find out OB. How much is that? It has traveled 1200 kilometers in 1.5 hour. So that is going to be 1800 meters. 1800. So we know this is 1800. Now this is 90 degrees. So from here on we can easily find out, according to the Pythagoras theorem, AB squared is equal to AO squared, which is 1500 squared plus 1800 squared. And if you do the calculation, it is going to be, you find the square root. AB is equal to, you take the square root on both sides. If you take the square root on both sides, and this is going to be 300 square root 61. You can do the calculation, 300 square root 61 kilometers. So the distance of the two planes after 1.5 hours is going to be 300 square root 61 kilometers. That is how you apply Pythagoras theorem. Great job, good going. I really appreciate the effort that you have put in to understand the concepts and applying the Pythagoras theorem to the application problems. Take up more and more problems and work it out on your own along with your friends also. So study collaboratively. Always remember, your results are in proportion to the efforts that you put in. So thank you very much for watching this video. Please share and subscribe my channel Wisdom Outlined, and looking forward for you to watch more videos of mine which will be upcoming in the future. Thank you.